Hi, my name is Matthew Mullis, and this is my Lab 1 report for Physics 2211 on the constant velocity. The purpose of this lab was to observe Newton's first law occurring in a real-world scenario, in which case this occurred by rolling a pool ball across a surface at a constant velocity and demonstrating the effects of Newton's first law. Newton's first law states that if an object is either at rest or moving with a constant speed and direction, it will remain in that state unless acted upon by an outside force. So, some of the key concepts for this lab is that when there is no net force on a system, that object has constant velocity. Newton's second law describes that the net force is equal to the object's mass times its acceleration. The velocity update formula says that our final velocity equals our initial velocity plus the net force divided by mass times the change of time. And the position update formula says that our final position equals our initial position plus the product of our average velocity and change in time. And our average velocity can be calculated by adding together the initial and final velocities and dividing them by the change in time. Along with this, the system, for this lab, will be the pool ball, and the surroundings is everything else going on: the floor, the friction force that exerts, and the gravity as well acting on it. So, as shown here, this was how we recorded the video of the ball moving on the it was recorded on phone, and then using the tracker software, we could model its position and velocity with respect to time. The origin was placed here at this corner, and then it's modeled as it's moving across this in the x direction. And the ball was rolled and maintained a constant speed as it traveled, or did not have any outside forces acting on it as it traveled. And then the predicted model here shows our position versus time as the ball was moving. The difference of these two models is that in real life, there are outside forces, mainly being friction, acting on the ball as it rolls. Whereas in this model, there are no outside forces acting on it because the model calculates the object's position and velocity with a net force equal to 0. Some possible sources of error could have been miscalculations using the tracker software, as certain frames could have been inaccurately calculating, causing discrepancies from what they actually were, as well as just due to the small amount of time this occurred over, the data could have been potentially a little bit skewed. So looking here at the code, we can see our initial velocity was moving at 0.7 meters per second, and the ball was just under being about 2 centimeters away from the origin when it started. And the ball was recorded to travel for 2.64 seconds. And in this model, where the net force is equal to 0, the ball maintained a constant velocity throughout this time. What this results in is showing that the model data is a linear line because with no net force acting on it, the velocity is staying the same, so the position increases linearly, while the track data shows that the position is kind of fluctuating and it's not moving this linear direction because of the friction force acting against it. So that is what causes this discrepancy between these two things. And finally, so the lack of net force, or the net force being equal to 0 in the predicted model, that is due to the two forces acting on the ball, in that case being the force of gravity and the normal force being enacted on it by the floor. And these two act in equal and opposite directions, canceling each other out, when in reality there's also a friction force opposing the ball, which would result in a non-zero net force. And if we were to use flip our x direction, it would just result in all of our x positions being negative, as they were originally positive as calculated before. Thank you for watching and have a nice day.